Hello, beautiful children. Okay, so now we are talking about combinations instead of permutations. Okay, so let's talk about the difference then. A combination is a way to calculate the total number of outcomes where order does not matter. So the example we just did above here, I forgot to write down the answer, sorry. Remember that was 360 ways to arrange 4 pictures out of 6. But each time I arrange them, it changes the order, right? If I have one in front of the other. So the arrangement matters. The order matters. In a combination, the order doesn't matter. So another way to think about combination is the word choose. Okay? I'm just choosing 4 of these out of 6. Something like that. Okay? For example, I'm going to explain this in a second, all of this mess here, but it's very similar to a permutation. But my example here, number 4, says out of 20 books, so I have a lot of kids' books for little Pythagoras. I want to figure out, well, how many ways can I choose just 5 of those to read to him, because I don't have time to read him 20. I'm going to do just 5 tonight. Now, does the order in which I read them matter? No, because it doesn't specify that in the problem. So I'm just saying, how many ways can I choose 5 out of 20? That's called a combination. Okay, so here's the formula. It's NCR, the total number of items, combination, and then R is how many you're choosing. And it's very similar. You do n factorial on the top, which is the larger number. But then you have to do this r factorial multiplied by n minus r factorial. Okay, so those are all of his lovely books over there. So how many different ways can I just grab 5 of them? Yes? Okay, so let's do that one with this formula. And then again, I'm going to show you how easy it is on the calculator. So here's how you would write that. 20 is your larger number, so that's going to be your n. Capital C for combination. And then 5 is how many I'm choosing. So that's 20 combination 5. Okay. There's also sometimes you're going to see this written in other ways. Sometimes this is written as 25 and then these weird parentheses. Okay. So if you ever see that written, it's the same thing, just different format. Okay. All right. So here's how this would look with our formula. You have 20 factorial on the top, right? You can look back up here, remember right here, 20 factorial on the top. On the bottom, you're going to have 5 factorial right here. And then in parentheses, 20 minus 5 factorial. Okay. So if you think about this, that is 20 factorial on the top. I'm going to leave this alone for now. And then I'm going to write this as 15 factorial, okay? Because 20 minus 5 is 15. Okay, so what this actually means is, if I were to write this as 20 times 19 times 18 times 17 times 16, but then instead of keep continuing on 15, 14, 13, I'm just going to write this as 15 factorial. So 20 factorial is the same as all of this right here. Okay, so when I write the denominator now, 5 factorial, don't I also have this 15 factorial here? So that means those two can cancel each other out. Interesting. So I'm left with this 20 times 19 times 18 times 17 times 16. And then 5 factorial is written as 5 times 4 times 3 times 2 times 1. You don't really need to write the 1, but you can. Okay, so you could type that in the calculator, but if you do, make sure you include parentheses for the denominator. Okay, it's very important. You can include it for the numerator, but It's only going to affect your answer if you forget the parentheses in the bottom. All right, but who wants to write all that when we have these nice little functions on our calculator? Okay, so let's see if I can do this fancy thing again. Yeah, okay. So I have my calculator here, I have my problem here. So all I'm going to do then is type 20. Oh, let me move this somewhere else. And then you go to math right here. Go over to probability. Over, right there. Now look at the third one down. See how it says NCR? Enter. So you type the 20, you type NCR, and then you type your smaller number, which was 5, and click enter. So 20C5, combination 5, is 15,504. That's a lot of different ways. Okay, a lot of options. Cool. Or again, you can write that as this right here, 20. This is read as 20 choose 5. 20 choose 5, or 20 combination 5, but they mean the same thing. Again, you're just choosing a small amount out of a large amount. Okay, so here's what you need to remember with combinations and permutations. I'm going to summarize a little bit. I'll write it right here before we go on to the next video. Let's do okay. So you need to remember, that for permutations, the order matters. And a lot of times you're going to see in the problem, it'll say something about how many ways can I arrange this. If you see that, you know it's a permutation, because you're going to have to determine if things are permutations or combinations. Combinations order does not matter, and a lot of times you're going to see the word choose. How many ways can I choose something? Okay? And let me leave you with one last little thing. This is a shorter video. You know how for your lockers, you get a lock, and it's called a combination lock? Is that accurate? No, it's not. Whoever came up with the name combination lock did not pay attention in probability, because when you do your code for your lock, doesn't the order matter in which you arrange the numbers? Yes, it does. So technically, those should be called permutation locks. So the next time someone says, grab your combination lock, you should say, no, that is a permutation lock, not a combination lock, because the order matters. And I forgot I was actually going to do this one last example with you before this video is done. So if you haven't already taken a look at your Pearson homework, this is an example that I got basically exactly from the homework. So if you want to pull that up, I can help you with it. Okay. All we've done so far in examples is we've figured out the number of ways to order or arrange or choose things. Now I'm going to do an example where we're actually calculating the probability of something. What is the probability of the oldest 3 members of a 10-member choir being randomly selected for a trio? Okay, so let's think about this. So if we want only the oldest 3 members out of a 10-member choir, if they are randomly selecting just 3 for the trio, just 3 out of 10, it doesn't say anything in the question about the order of those people, right? If I choose these 3 people out of a group of 10, it doesn't matter how many, it doesn't matter what order I pick them in, I'm just picking 3 of them. So notice how it didn't say the word choose, but it's saying we're just randomly selecting 3 out of 10. So that means that the order does not matter, okay? Which means we are dealing with a combination or permutation. That's right, a combination. The order does not matter in combinations. Okay, so before we do anything with probability, we need to figure out, well, what's the total number of ways I can choose 3 out of 10, right? So how many ways can I choose 3 out of 10, which can be written as that, or more commonly, what we're going to be doing is this 10C3, 10 combination 3. Why don't we just use our calculator instead of doing the formula, because that's what they're here for. Just saying. Okay, so I'm going to type 10, and I'm going to go to math. I'm going to go over to probability and down to the combination. 10 choose 3, or 10 combination 3, is 120. So there are 120 ways to choose 3 out of 10. But I want to know, what's the actual probability that that I am selecting the 3 oldest members, right? Well, there's only one way you can do that, right? Because there's only 3 oldest members. I can't have, I'm not talking about 4 oldest members, or their age is not going to change depending on if I pick them or not. Their age is already set. So there's only one solution, or one event, in which I have 3 of the oldest members chosen. So when we talk about probability of choosing the 3 oldest, remember, you want the total number of outcomes, the number of outcomes in the event, and then you want the total number of outcomes possible. So in this event, I can only have one event where I have 3 of the oldest, but there are 120 different ways to to choose those 3. So you would do 1 divided by this 120 that I got here. So I'm going to do that on my calculator. You can either leave that as a fraction, or you can say, what is that as a decimal? So 1 out of 120 is 0.0083. Or as a percentage, that would be approximately 0.83%. Okay, probably Pearson's going to ask you for the fraction. So there you go. Okay? All right.